Dear ladies and gentlemen, in my presentation I would like to report on comparative analysis of smart city platforms. The materials given in this paper were developed by the authors according to the results of investigations carried out during 1 year in the virtual scientific research laboratory the smart city of Ternopil at Ternopil Puluj National Technical University. The concept of transforming cities into smart ones is gaining intensive development in the world and in Ukraine. In order to achieve the status of smart city, it should meet the criteria regulated by international standards. The cities of Ukraine consider this problem to be somewhat simplified and consider the city to be smart if it meets at least the following conditions: achievement of sustainable development in economic, social and environmental spheres, economical use of natural resources, citizens' participation in city management. City infrastructure uses information technologies for the improvement of the residents' living conditions. In order to achieve the development and status of the smart city, various information technology platforms are being developed. The requirements for them are formulated by municipality. The objective of this paper is to carry out comparative analysis of the existing platforms of smart cities, their main functionality, areas of application, which will become the basis for the development of requirements for information technology platform for Ukrainian smart cities. Michael Master and Rania Algazar believe that smart decision-making is based on the aggregates of data, considering several application areas of smart cities. Information systems play an important role in the development of smart cities. The authors note that the data can be combined with historical data or other open data from various sources, being the basis of decision-making. Simon Jones argues that the conceptual presentation of the smart city is based on the application of digital technological systems for urban infrastructure and management processes, implies the return to more modernistic, rational tradition of planning, focused on digital technology as standardization of the decision-making processes, suggests to turn back from urban spontaneity, focusing on economic growth due to digital technological innovation. The next slide shows the main characteristics of smart city platforms. In terms of platforms, smart cities have a number of important components, such as connection to IoT, various sensor communication devices, big data analysis, cloud and security, as well as blockchain and artificial intelligence. Areas of application should include transport, power engineering, environment, city administration, and security. Smart city platforms should satisfy all paradigms, such as shared economy, public relationship, business model, and data management. 3 smart city platforms were considered for further comparison. The next slide shows the main characteristics of smart city platform 1M2M. 1M2M platform created in July 2012 in order to develop IoT service platform standard and has become the international standard service platform established by 226 companies, including mobile operators and decision-making companies. The main service areas are smart homes, smart cars, smart networks, and healthcare. Common platforms provide standardized service APIs that connect different heterogeneous IoT devices. 1M2M provides the structure of resources for sensors to obtain their information, supplies semantic information about the content of the resource and the functionalities that use it. Functionality provided or extended due to semantics includes queries, openings based on semantic descriptions, analytics support, support for creating associations, for example, activation of IoT scenarios. Software with information use is able to specify what information is required and to receive notifications in case of relevant changes. To define clearly the syntax and semantics of information so programs can decide whether they can process it, which module is required for processing. At present, 1M2M is the international demonstration project used in Busan, Daegu and Goyan, South Korea, to provide services such as transport, healthcare and environment. The main characteristics of Smart City platform Fayvare is presented on the next slide. Fayvare is an open-source platform that stands out for the standardization of smart city platforms in Europe, provides various components and supplies NGSI and context brokers, the next-generation interface based on Open API. The Japanese Electric Corporation NEC, which is used at present in the countries around the world, is also creating its own security platform using Fayvare open source. The general idea of the platform is data collection from various sensors installed throughout the city. These sensors should collect data such as temperature, humidity and concentration of fine particles, PM2.5 and PM10. The obtained data provide easy-to-use information panel. Their visualization by means of geographical map, table and various diagrams. Selected data are combined with external data, regional weather data, in order to create predictive model regarding solid particles concentration. Fayvare platform is grouped into 7 main parts, called common tools. Each of them represents specific aspect of Fayvare services and provides one or more components, along with reference implementations supporting the specified APIs. In addition, there are so-called domain-specific activators that provide components for certain domains, such as health, energy, The basic components of Fayvare platform implementation include Context Broker Orion is persistent data storage with REST API. Management of server devices EDAS provides REST endpoint with API required for the register of donors and operation with their data. Storage of time series data STIGNAS. This component is essentially Apache Flume extension used to store updated and persistent storage. It listens to input data, which are then forwarded, according to internal configuration, to one or more data receivers. Other possible data receivers include MongoDB, HDFC, and PostgreSQL. Therefore, Fayvare creates a new generation of intelligent applications using large-scale contextual information in real time. The efforts are focused on promotion, compatibility and free flow of data within and between cities, cooperation between cities in order to adopt common standards, which can create the landscape of diverse but interacting smart city solutions. Fayvare contributes to the creation of a significant market where the developers can start investing and cities provide the basic for data economy development. Slide represents the main characteristics of Smart City platform Cisco Kinetic for Cities. The Cisco platform provides the opportunity to collect data from various types of devices and sensors in response to city requirements, to analyze cross-domains and the APIs as open platforms, as well as to manage security keys. The platform includes API for such domains or urban services as outdoor lighting, parking, urban mobility, crowd traffic, environment security, waste management. Cisco Kinetic for Cities platform is delivered as the cloud service or local deployment model. The platform collects data from sensors using security network connection, both wired and wireless, to transmit this data to the cloud. In general, the platform provides a convenient interface for the city operator where he can see the dashboard with up-to-date data and graphs, as well as adjust policies according to the city requirements. Based on Cisco Kinetic for Cities platform, Cisco company also provides platforms and solutions for Busan Smart City and Songo Smart City in Korea. The next slide shows a comparative analysis of information technology platforms by SATI method. In this paper, we have chosen the criteria, functions, tools, characteristics, implementation for comparative analysis. The carried out expert assessment based on these criteria makes it possible to build the hierarchy for choosing the best implementation of the Smart City platform. The results of expert assessment of 10-point scale are presented on this slide. Based on these results of expert assessment for the investigated Smart City platforms, let us determine the best platforms by means of SATI method. We can see on this slide normalized matrices and pairwise comparisons of criteria with regard to the goal. Normalized matrices of pairwise comparisons of alternatives with regard to functions criterion and tools criterion are presented on current slide. This slide shows normalized matrices of pairwise comparisons of alternative with regard to characteristic criterion and implementation criterion. The significance vector of global priorities of alternatives are represented on this slide. As conclusion of the investigation, we have got that one M2M platform is the winner with 53.2% advantage, with significantly weaker Cisco 26.9%, and the Favara platform has the lowest mark, 19.9%. According to the results of the investigation, we can confirm that, first, the platforms provide almost the same functionality, but such characteristics as user interface, speed of big data processing, fault tolerance, availability of backup power supply in the city sensor system, and a number of their characteristics should be tested directly at the stage of smart elements implementation in the specific city. Second, at present, Ukraine has chosen the direction of digitalization, and smart elements are being actively implemented both at the city and state levels. Third, should be noted that at present there are only platforms that manage the specific city. In order to solve these problems, each country should build standardized data formats rather than independent platforms. And due to this fact, it is necessary to focus on using data by data center platform, which connects platforms between cities and connects common data together include infrastructure. Thank you for your attention.